I hope I'm audible enough. So parallel vectors. So we say vector U is equal to AI plus BJ plus CK. So vectors U and V is PI QJ RK. So you say these two vectors are parallel if A over P is equal to B over Q, which should be equal to C over R. As simple as that. An example so that you understand well. Let me pick it from the same material sheet. We are given vectors V is equal to I minus 4K and W is equal to 9I plus 3J plus K. Solution. So we have I. So instead of me, I'm not picking the i's, I pick 1 over 9 for this side is equal to, there's no j here, meaning it's 0 over 3 equal to -4 over 1. But as you can see, this is not true. So because the equality is not there, then I say V and W are not parallel. Like that. That was 1. 2, given V, so now let me use different ones. A is equal to 2I plus, is it 4J plus 6K, and B is equal to I plus 2J plus 3K. You want to check if these two are parallel. So you say 2 over 1, is it the same as 4 over 2? Is it the same as 6 over 3? For sure, this is 2. So A and B are parallel. Then 3, I'll just mention it here, that vectors A and B are perpendicular if A dot B is equal to 0. So once you get a dot product and you find that it's 0, then you know that the vectors given are parallel. Are perpendicular. Any questions? You want to cross over? I get question. Okay. Is this a question? Let me give you an example of the perpendicular. We can just explain question 1 again. Question 1 and 2 are the same questions. You are dividing the I component divided by the I component of the other vector. And you want the ratio you get to be equal to when you divide the J component over the J component of the other vector. But if the two are not equal, then you say the vectors are not parallel. You want to, when you say 2 over 1, I get 2. 4 over 2, I get 2. 6 over 3, I get 2. Because I'm getting the same things, it means that two vectors are parallel. But here 1 over 9, you get 1 over 9. 0 over 3, you get 0. The two numbers are not equal. You're not convinced, check again. Negative 4 over 1, you get negative 4. The numbers are not equal. Even if 2 were equal, we want all the 3 to be equal. It should be this case. When this fails, then there's no, then you say that the two vectors are not parallel. An example of perpendicular vectors, not perpendicular, but just answering a question that's asking about perpendicular. You can go back to question 2 and check if A and B are perpendicular. So you get a dot product. So you write 2, 4, 6. Dot 1, 2, 3. And then multiply. So I have 2 times 1, I get 2 plus 4 times 2, I get 8 plus 6 times 3, I get 18. And then you add here, I'm getting 28, which is not equal to 0. So A and B are not perpendicular. Like that. Okay, maybe you want to which are perpendicular. A is 1, so I minus 3J, maybe plus 2K. And then B is negative I plus so let me do this. So this is 3I minus J third one. Let's 3 plus 3. I want to put an example which is going to put a list. Okay, let me do. I put 2 here. 2I. Then I put plus 2J. 2, 6, 4, plus 2K. Yeah, just like that. So here we're going to have, when we do A dot B, we'll get 1, make 3, 2, dot 2, 2, 2. This will be 1 to give us 2 minus 6 plus 4, which is 0. So because the dot product is 0, so A and B are orthogonal. They are orthogonal. So orthogonal is the same thing as saying they're perpendicular. Okay. So let's go straight into calculus now. Tutorial sheet. We'll start with the tutorial sheet. Limits.
So a previous screen.
Wait, I don't know if I missed it, but did you happen to talk about, I think it's called the vector crosses or something like that?
The cross product.
Thank you very
Yes.
much.
Yeah, we did. I hope you didn't miss that class. It's just the determinant.
No, I think I've attended all the classes on vectors, but I don't remember seeing the cross product.
Oh, you must be right. If you don't remember. But how come? You should have. Okay. The vectors that cross. That's what you have put there. So cross product. How do you get cross product of two vectors? I think we didn't do. Okay. So get an go straight to an example. I think you understand the examples easily now. Things that looks like theorems. So an example here. Find the cross product U cross W. A given U is equal to 6i minus 3j minus 4k, and W is equal to I minus 3k. So you do. So you say U cross W is equal to, write in the determinant form. You start by putting I, J, K, and then pick 6, -3, -4, and then pick 1. Because there's no J on W, we put 0, and then -3. Then now calculate the determinant. So using our odd way, I picked I, and then I cut like that. Then I get the determinant of the remaining thing. So that would be -3 times -3 minus 0 times 4. So we're getting 9 minus 0, that's 9, and then minus J. So you cut here and you cut here. So you have 6 times 3, -3, minus -1, minus 1 times -4. So we're getting 6 times -3, -18, minus -1 times, in 1 times -4, we get -4. And then plus K, then you cut. So you get 6 times 0, that is 0, minus 1 times -3. So we have 0 minus 3. This will be 9i. This is -18 plus 4, which is -14, times -j, we get plus 14j, and then plus 3k. This is the cross product vector. What's the difference? The dot product is a number. And then the cross product is a vector. As you can see, the answer is a vector. And that's how you get the cross product. Then determine whether the vectors u is minus 2i plus 4j minus k, v is 5i minus 2j minus k, and w is 3i plus 4j minus 3k lie on the same plane. So how do you do that? Well, this question is exactly the same question as being asked to find the volume. Find the volume. Excuse. So we can also just say find the volume. But when they say tell me whether the vectors lie on the same plane, they want you to interpret the meaning of the volume that you get. So what we do is we say, okay, I'll just get the volume of this, which you get by getting the determinant. So I go to vector u and get -2, 4, -1, and then 5, -2, -1, and then 3, 4, -3. So because we have 3 vectors, there's no need of going to writing ijk, because we already have 3 vectors. So if we do include ijk, you have a 4×3 vectors, you can find determinant. So now here you get determinant. So we put -2 and then remove that. So we get -2 by negative, that's 6 minus 4. So we get 6 plus 4, which is 10. So we have a 10 here. And then -4. You remove this, remove that. You have -15 plus 3. So -15 plus 3, which is -12. And then -1. You remove like that. So we get 20 plus 6, which is 26. So we have 26. So here we get -20 plus 48 minus 26, which is equal to +2. So if they just said find the volume, you would have said, oh, the volume is 2 units cubed. But now they asked if the vectors lie on the same plane. So you say, since the volume is not equal to 0, then vectors u, v, and w do not lie on the same plane. This, when they ask you to find the volume, don't say we're not taught. We have found the volume here. And it's the one we use to tell if the vectors lie on the same plane or not. If we found that the volume was 0, we would have said the vectors lie on the same plane.
Tensor.
Mm-hmm.
When putting the coefficients there, I mean, does it matter which vector comes on top, second, or third? Because there we
No,
started.
it doesn't matter.
It doesn't.
Mm-mm.
I would say the same question is the same as being asked to find the volume or what?
Yeah, I said that this question is asking you to find the volume and then interpret it. The volume of vectors that lie on the same plane is 0. Or maybe let me ask you a simple question.
Sir,
Just a minute. Find the volume of this. If this is 4, this is 7. What's the volume of this shape? Okay, what's the formula for the volume of the rectangle?
LB. LB.
Can't be LB. So the volume here is 0. Because remember the volume should be L, B, H. We need 1, 2, 3. And that's the reason why we say units cube. Because we have that kind of thing is dangerous. So this is the reason why we are saying, well, if the volume is 0, then it means they lie on the same plane. Because if the volume is 0, then you have a plane. You have a plane, and not
a plane like no height.
Yeah, like no height. They're just on the same plane. But if they don't lie on the same plane, you have this. We have this structure where it will give you. You always have the base, the width, and the height.
So, sir, what if we are asked to find the if 2 vectors now lie on the same plane, not 3 vectors?
2 vectors lie on the same plane. You just check.
Hey, is it possible?
Yeah, it should be possible. You know, look, the only way we can ask you if 2 vectors are on the same plane, we'll ask you in, maybe we want to ask like this. Let's say this is a plane, and then I've got this vector here. Then we have maybe another plane, and then there's this vector here. And maybe there's a vector that is cutting across. Or if it was in the same plane, then there has to be a vector that is like this, maybe like that. So if I want to talk about 2 vectors, maybe we won't necessarily ask if they're on the same plane. We'll just say, okay, maybe you tell us if they're perpendicular or they're parallel. Because if they're parallel, then you understand that the distance on the plane is just an extension. So you only be asked there to check if the vectors are maybe perpendicular or they're parallel. But this issue is mostly asked for 3 things. Then there's a
Finding
question.
a vector.
So wait a minute. There's a question that what's the difference between, what did you say? What's the difference? What's the difference knowing if it's perpendicular and if they lie on the same plane? Since you're talking about 0, 0, Perpendicular, you get the dot product. If it is 0, then they're perpendicular. To lie on the same plane, you get the cross product. If it is 0, then in fact, when there are 3, if you want to use a cross product, you say U cross V, then the third one you dot it, W. It's the same thing as getting, this is a shortcut, as just getting the numbers. As just getting the numbers, and then the components in U, in V, and in W, then I get the determinant at once. We call it the shortcut because for you to get U cross V, obviously to be determinant. Even if I come and dot here, I've already found the determinant. So why not just going straight into the determinant and have everything done there? That's the difference. So what was the other question?
I mean, if you are told to find the vector which is perpendicular to the given vectors, to both of them, do we use the cross product or what?
Use the cross product.
So like that vector that we found in the first place was perpendicular to both, was it U and M?
Yes. Let's go back. Which one did we find? Find the cross product of U, visit. So question
Yes.
one, we found this as the solution. Question one, we found this as a solution. If they asked us to find a vector which is perpendicular to vectors U and V, then you get the cross product. This answer here is perpendicular to any of these two vectors. If you want, you can sample. Let's do U cross the answer. I mean U dot the answer. So we'll have 6, -3, -4. Dot 9, 14, 3. So we'll have 6 by 9. That is those are fast.
56, I think.
56. Okay. Plus -3 by 14. That one. This is 54. And then 14 by 3.
-42.
So -42. And then plus -12, is it? So when you add this, that is 54 minus 54, which is 0. Showing that the two vectors are perpendicular. So the answer you get from the cross product is perpendicular to both vectors. Another question?
So a quick reminder on how we find an angle between two vectors. Yeah, kindly remind us, I've forgotten.
On how to
find an angle between two vectors.
Okay. So find theta between vectors U is equal to 1, 3, 4, and V is equal to -3, 2, -1. So we know that, well, we can use sine or cos, but sine is long because it goes through the cross product. Because we have two formulas. We have A dot B is equal to A, B cos theta, or A cross B is equal to A, B sine theta. So if we use sine, we'll have to get the cross product. If we use cos, we get the dot product. So in this case, we just get U dot V, which is 1, 3, 4, dot -3, 2, -1. That is 1 times -3, we get -3 plus 6 minus 4. That's -7 plus 6, which is -1. So what we want? We now want the magnitude of U, which is the square root of 1 squared, 3 squared, 4 squared, which is 1 plus 9, 10 plus 16, 26. Also get V magnitude, that is -3 squared plus 2 squared plus -1 squared, which is 9 plus 1, 10 plus 4, 14. Then from there, we get, we substitute here. So this side we know, we have -1 is equal to here, root 26 multiplied by root 14 cos theta. So meaning that cos theta is equal to -1 over root. You can even multiply 26 by 14 inside there. So 26 by 14, we get 364. So it means that theta is cos inverse of -1 over the root of 364. If it was a special angle, we would have found it. But like this, if the calculators you end here, if the calculators you punch, you find an angle.
Yeah.
Yeah, and that's how we're answering that question where you're given, where we're given in the Toro sheet, you are given that the magnitude of A is 1 over 4. The magnitude of B was given as 9 over 4. Then they said the angle theta is pi. Then they say find the dot product. So you use this formula. So you say A dot B is 1 over 4 given as the magnitude of A, 9 over 4 given the magnitude of B, and then cos theta. But we know this is just -1, so we have -1 by 9 over 16. So we're getting -9 over 16. That's our answer. We just substitute in that formula. So if they gave, or they can give you the cross product and then ask you to find theta, then you know I have to use sine. Like that. Okay, so we'll have a 10 minutes break. No, 12 minutes. So join at, this is 18:48. We'll join at 19 hours. Want to do tutorial sheet 9. You should be able to finish it today. So let's break a bit. I think I can't take that question. The thing will be breaking in time since you can't.